Okay, so now we will talk about another really important property of tree, and that property is called as diameter. So you have been given a binary tree and you need to find its diameter. How many of you heard about diameter of a tree? Can you define it for me? What is diameter of a tree? You must have heard about diameter of a circle. So I think everyone heard about diameter of a circle, right? This is a circle. It has a center. What is diameter of a circle? Can I say diameter of a circle is, if I call this point 1 and call this point 2, this is the longest distance between any 2 points. That is how the diameter of binary tree is also defined. It is longest distance between any 2 nodes. If there is a tree and you select any pair of nodes, N1, N2, then how many paths are there in between N1 to N2? One and only one path, correct? Via sequence of edges. So let's take a quick example. I'll want you to find diameter of a particular tree. Let's say you have 1, 2, 4, 6, 4. Okay, let's take this 7 and this 4. Can you tell me the distance between this 7 and this 4? By distance, I mean how many nodes are lying along that path. How many nodes are lying along the path from the 2 underlined nodes? So if you have to go from this 7 to that 4, you will go like this, like that, and like that. So this is the path, and along this path, the number of nodes are 1, 2, 3, 4. But if instead of taking this and this, if you take this and this, now can you tell me how long the path is from here to here? So you have to go like this, that, this, that, this, that. So the number of nodes along this path, as you can see, are 1, 2, 3, 4, 5, 6, 7. And this looks like the most promising, the longest path. So the diameter over here is 7. Some people also say that the 2 nodes between which the distance is maximum, those 2 nodes have to be leaf nodes. Certain people conclude that. Is that right? And that is not true, because if I, let's say, tell me the 2 nodes between which the distance is maximum, 1 and 5, right? If you consider 1 and 5, the distance between them is this, which is of 1, 2, 3, 4 units, right? And is 1 a leaf node? 1 is not a leaf node, correct? So never ever say that diameter is longest distance between 2 leaves. Certain people say it is longest distance between 2 leaves. No, it is longest distance between 2 nodes, and those 2 nodes can be anything. Certain people also say that, hey, the diameter of a tree, which is the longest path, will always pass through the root. Like in this case, this is that path which gives your diameter, and it is passing through the root. So sometimes people say it will always pass through the root. Is it correct? The answer is, again, it is not correct. So we can have a quick example. Let's say you have got what is the longest path over here? Which 2 nodes will you pick? The 2 nodes that you will pick over here will be 12 and 7. If you pick 12 and 7, then this is the path that you will have. And this path clearly does not pass through your root. So the way to go is recursion. But how exactly can we use recursion? See, when you are doing 1 plus, you are always taking into account the root. But I told you that you don't know that which nodes your diameter will be passing through. Listen to it. It is a very important point. You don't know which node your diameter will be passing through. In case of height, you knew it, that height will always pass through the root. But in case of diameter, it is not necessary that it will pass through the root. It can pass through any other combination of nodes. It's not known. So let's think of it. It's a good problem. It's a well-known but a good problem. If you conceptually understand it, you will be able to solve many questions on trees on your own. So let's conceptually get it. See guys, can I say that diameter will be a path which will take turn around some node? It will take turn around some node n. When I say turn around, like here it is taking turn around this node, and in this example it was taking turn around this node. Now what is that node where turn around is being taken? That I don't know, but there will be a node for sure where a turn around would be taken. Yeah, in cases like this you can argue and say that there is no turnaround, but I would say, hey, I can consider that, hey, this is the point where turnaround is there. It's just that the other part is empty. Okay. If I have been, let's say, given a tree, if I've been given a binary tree, now what I'll do is for each node, I'll assume it as my turnaround point. So assume it as my turnaround point. If this is supposed to be my turnaround point, then what is the longest diameter? Then what is the diameter that I can have? Then what is the longest path that I can have? So in other words, can I figure out the longest path that passes through it by taking a turn around from here? So the answer to that is very simple. If there is a node, let's call it n, and if it has a left subtree, call it LST, and has a right subtree, let's call it RST, then the longest path that passes through it by taking a turn around will simply be equals to 1 plus the height of left subtree plus the height of right subtree. That is the longest path that passes through it and takes a turn around. Now, if you compute this thing for all the nodes, then the maximum value of this, which you get for some node, that will be your diameter. Like if you are computing this expression for this node, this node, this node, this node, this node, all the nodes, then whichever node gave you maximum value of this, that maximum value will be your diameter. And why I am calculating it for all the nodes? Because I don't know what should be my ideal turnaround point. Just to get more comfortable, I'll draw one more tree. Let's say we have 1, 2, 3, 5, 7, 6, 11, 4. And let's say here we have 8, 9, 10, 7. Think of it in this way. If you compute this expression for all the nodes, what are the values that you are going to get? Can you tell me the value of this expression for this node? If this is my turnaround point, then what will be the value of 1 plus height of left and plus height of right? So for this node, what is the height of left subtree? The height of left subtree is 1, 2, 3, 4, 5, and the height of right subtree is 1. So 5 plus 1 plus 1 is going to be 7, right? Now let us compute this expression for this node. What will be the value of this expression for node 3? For 3, the height of left subtree is 0. The height of right subtree is 0. So 0 plus 1 is going to be 1. Similarly, if you compute it for this 2, you have already computed it for 2. That turns out to be how much? I believe 9. The height of left is 1, 2, 3, 4. The height of right is also 4. 4 plus 1. So similarly, if you list down this particular value for all the nodes, whatsoever will be your maximum, that will be your answer. So this is the idea. So you can very easily code this idea if you remember how I had written the code for finding height of a tree. Height of the tree rooted at root is equals to 1 plus maximum of height of the tree rooted at root left, comma height of the tree rooted at root right. Okay. So I'm going to write something on the board, guys. Imagine there is a big tree. Okay, like that. This is some tree. It has LST and it has RST. So I'll illustrate you that we have talked so much about it, and now whatever we will be writing, it will be written in terms of left subtree and right subtree again. So if I have to find the diameter of the tree rooted at this root, then I can say my first option is that the path which corresponds to the maximum height passes through this itself and takes a turn about it. So that will be equals to 1 plus the height of root left, which is height of this subtree, plus the height of root right. But this is just one possible option, because in this case also, this was not the diameter. So what are the other two options, or what are the other options? The other options are that my diameter could either be contained entirely in my left subtree, or it could be contained entirely in my right subtree. So my diameter could either be contained entirely in left part or entirely in right part. So if dia of root tells me the diameter of this, then dia of root left will tell me the diameter of this recursively. Similarly, dia of root right will tell me the diameter of this. So the second option that I have is dia of root left. And the third and final option that I have is dia of root right. And whatsoever is the maximum of these three values, that will be the diameter of root. So just summarizing it again, if you have to find diameter of a tree rooted at root, then the first option is that this root itself is the turnaround point for which this expression is written. And the second option is that the diameter is entirely contained in this. And the third option is that the diameter is entirely contained in that. And whatsoever is the maximum of these three things, that will be the diameter, overall diameter. So there can be a height function which takes the root of the subtree whose height you want to compute. So you can just call it. Okay. So you can, so if you pass to this, height function, this node, then it will return you the height of this tree. If you pass to this height function, this node, then it will return you the height of this tree. So whenever you want to compute height of a subtree, whether it is left subtree or right subtree of a node, you just have to consult this person or this method, right? And then you can keep on recursively calling this method again and again. So if I have to write a code for this that aligns with this idea, I'll say there is a method that returns me diameter, and it takes the root of the tree, the original tree. And then what it does is it returns me the maximum of three things. So what are those three things? The first thing is 1 plus this entire thing. I'm just copy pasting it over here. The second option is make a recursive call for your left subtree. And the final option is make this recursive call for the right subtree. That's it. So this is your recurrence relation kind of thing, but there has to be one termination condition also. So whenever from a root, you are making calls to your left and right, that means you are coming down. You're coming down and down and down. So eventually, let's say if you were here, you will make a call to null also. What's the diameter of an empty tree? The diameter of an empty tree is 0. Does it mean that I can add a termination condition saying that, hey, if my root is ever null, then just return 0. Otherwise, do this chunk of task. And what is this? First, compute the height of the left subtree by making this call. Then compute the height of right subtree by making this call. Figure out this value. And then try to find the diameter in left subtree and then the diameter in right subtree, and keep doing this thing on and on and on. Can you talk about the time complexity here? If there are n nodes, how many operations we are doing? You know, it is definitely not order n, because at each node, you are making call to this height method. So when you are here, you call height method. When you are here, you call height method. When you are here, you call height method. And call to height method, is it order 1? Does height method work in order 1 time? The answer is no. The height method works in order n time, where n denotes number of nodes of the subtree whose height you are trying to compute. So in the worst case, what will happen is if you have a skewed tree as your input, then you will call your diameter function for this node. Keep looking. When you call your diameter function for this node, you will first try to find the height of this much part. When you try to find the height of this much part, if these are n-1 nodes, this thing will take n-1 time, right? Now, when you recursively call diameter function for root right, and when you are here, you will now try to compute the height of this much part, and it will take you n-2 time. Then when you are here, you will try to compute the height of this much part. It will take you n-3 times. So it will go till 1. So the sum from 1 to n-1, it will roughly be n square. And why is it happening is because you are first asking this to give you this much height, and then you are asking it to give you this much of height, and then that much. So a particular node is getting touched again and again and again. So those of you who are really thinking deeply, you will understand that whatever we are doing over here, according to this particular thing, is a very, very stupid thing to do. Why it is a stupid thing to do? Because think of it in this manner. If this is a tree and you ordered height for this much part, if you ordered height of this much part, can you think how would it internally have been computed? It would have been computed by first finding the height of this much and then finding the height of this much. And then again, for this to be computed, it would have computed the height of this much and then the height of that much. So what is happening is, in one call to the height only, the height of all the subtrees are being computed internally. You get overall height after you have computed height of all the subtrees starting from bottom to top. So if you are ordering height again and again, like once you were here, you ordered height for this and that, and once you are here, you ordered height for again this and that, then this is not a great thing to do. So what you can do is you can modify your height method and you can get your job done. Now, what I mean by modifying your height method, so let's talk about it. Let's say you have something like this. Okay. Now, you know how it works. So if you call height function on 1, it will call height function on 2, and then it will call height function on 6. Now again, from 2, you will call height function on 4, height function on 3. From here, you will call height function on null, height function on 5. And from here again, height function on null, height function on null. Now you see what happens. So from null, you anyways return 0. Again, from here, you anyways return 0. You anyways return 0. Can I say that whenever you are at a node, you have your left height also, and you have your right height also. Like once you return from here, then at this node, you have your left height also, and you have your right height also. Similarly, when this returns and this returns, you have your left height also, and you have your right height also. So whenever a control comes back to a node from bottom to top, you have your left height as well as right height. And if you have your left height and right height at each of the nodes, then you can very easily compute this thing, which is 1 plus LH plus RH. And now what you can do is you can have a global variable, which is answer. You can initialize it to 0, and you can keep on maximizing it. So at each node, you can say answer is equals to max of answer, comma, 1 plus LH plus RH. So all that we are doing is we have a global variable answer, which is initially 0. And now we know the way our height function works is whenever control returns back to a node, we know its left height and we know its right height, and we know it for all the nodes, right? So what I'll do is I'll create this expression, and if this expression is greater than answer, I'll update my answer. This answer is a global variable, or you can pass it by reference if you want. The job will be done. How many of you can code this logic? I mean, no need to worry about that. You just have this recursive method. You just plug this thing inside that recursive method and job will be done. So I'll write it for you. So I'll write height function again. Let's say I have a get height, and it takes the root of the subtree whose height is to be computed, and you're passing answer variable by reference. You want, you can keep it global. You know, I would advise you against global variables, because on certain platforms, global variables, they behave very, very abruptly. Okay, so let's keep taking a look at this code. This code is not responsible for giving you diameter. This code is responsible only to compute height of the overall tree. Okay. So what did we write here? If our root is null, return 0. Otherwise, what was the first step? Get the height of left. Get the height of root left. Okay. Store it in some left height. Similarly, get the height of root right. Okay. Now, this get height method is being recursively called. So it will be called for this node, this node, this node. It will be called for all the nodes. Now, if the control comes back to this node, you will have left height also. You will have right height also. So if you have left height and you have right height, so you can create this expression. And if this expression is greater than the current value of answer, you can update your answer. So you can just put a line over here. Answer equals to max of answer, comma, 1 plus LH plus RH. And then return the actual height, which is 1 plus max of LH, comma, RH. So, this is the only new line which has gotten introduced over here. Everything else is still the same. You are still at a node, you are getting LH, RH, and you are returning the height by using this formula to your parent. So while the height is getting computed, you very silently put this line and compute diameter also. And how you do that? You know the left height, right height for all the nodes. You know 1 plus LH plus RH, and you use that to maximize a variable answer. And what will be the time complexity of this code? Will it still be order n square? The answer is no. It will be order n, because what was the complexity of height method? The complexity of height method was order n, and you are doing nothing to change it. You have just added one new line, which is doing some constant number of operations at each node. So it will continue to be order n.